Welcome to the internal SSbD training of the Planets project. Next, we are now looking into practical exercise and look into the specific case of the JRC gasket plasticizer. And this will be provided by Josephine Steck, giving us an insight into the Planets workflow of SSbD. And I will, Martin Himmli from the PLAS, give you an introduction into the plasticizer case that has been used also by the JRC before.
Okay, so now it will be an easy piece of cake because Sabine, Norbert, and Carla have explained everything very well. So, based on what you have seen before, we have developed our Planet generic SSbD workflow to be followed in the case study. This workflow is divided in two main phases. First one, the scoping, and second one, the assessment. This is basically what Carla shown you at the beginning of her talk. The scoping phase is divided into three parts, which mostly answer the why, what, who, how mentioned by Norbert and Sabine. So you have the who, with the actors in the technical value chain, but you will see later also in the assessment phase with the SSbD expert contact list. So it's how we answer to the who. For the how part, we have all the assessment in blue. We will not discuss that in detail today because other workshops are planned for this part. How now to answer to the why. The why is the motivation for substitution. Why do we need these new chemicals to redesign this process or this new application? And what is mostly the SSbD specification, which is now in our case divided in three parts, two sequential and one parallel, the redesign definition and the system definition and the regulatory landscape. Sabine already highlights the importance of the regulatory compliance. So this will be developed in this part, in the case of Planet. So today we will focus our presentation on the scoping phase, as you already understood, which aim mostly to formalize the system under study and to ensure efficient SSbD assessment later on. So I would like to offer that we go now on the hands-on, Martin, and go in detail into these three parallel action in the scoping phase.
Yes. So if you, as you have access to our SharePoint, go to the work package 8, you will find a folder that is recognizable as first internal SSbD workshop or something. And there are some PDFs. Two PDFs are relevant for the later work. And one PDF is the case description, which I'm shortly doing with you guys now. And the second one is basically the questions that we can then use as guiding questions through these scoping action items that were explained by Josephine right now. So there will be these 4 slides on this one PDF on case description, just that we can all play on a kind of case, and this is not IPR sensitive to any of our company partners here. We selected a case that has also been one of the cases during this case studies of this with the stakeholders during this stakeholder engagement phase of the JRC. And I guess even Carla has mentioned it earlier. So we are going to be playing here on this plasticizer in the food contact materials, and this plasticizer is used for sealing gaskets in these glass jars. So it's basically on this these metal things here that you use for closing and they're closing the glass stuff where, I don't know, fruit, marmalade, tomato juice, whatever can be in there. So it can be have all these different types of chemical ingredients as well. So it could be in alcoholic, free fat materials, pH, alterations, fruit acids, etc. can be there, and storage conditions need to be somehow considered that are quite spanning over quite a range in the use phase, like between 6 to up to 48 months at room temperature, or a couple of days in the fridge, or maybe in the freezing, in the freezer at -20 or something like that. End of life scenario would be, these materials are single use, so in the end they end up in the municipal waste. Basically, so these would be also considerations for the sustainability assessments eventually. The plasticizer add up quite to a significant percentage of the material in the end, so up to 35 to 40% by weight. Their job is basically to enable workability, extensibility, flexibility of the material, also to keep the material inside sterile. The substance of very high concern, which was identified in this plasticizer, is the DEHP, D2-ethyl hexyl phthalate. It's toxic for reproduction, category 1B, so also an endocrine disruptor, and for human and the environment was annotated to the substance. And we, in contrast to the case study of the JRC, would just kind of confine for today to compare it to two alternatives. And one alternative is actually a bio-based one, so it's this epoxidized soybean oil, ESBO, and the other one is acetyl tributyl citrate, ATBC. What we will now do in the next 1 hour and a bit more, and we are about 38 people at the moment, so we will probably form 3 breakout teams. I would like that we are not kind of collaborating in our typical company groups, but we would then kind of just form quite heterogeneous groups from different areas, academic, industry, different industries, and so on. And we will also have some facilitators there that help you primarily by using the mural, because the mural we will use to document basically what it will be worked on. And we are going to be conducting 3 actions. The technical value chain definition, which is the action 1 in our scoping phase. So the upper leftmost in the green area action item. So we keep about 10 minutes for that. Then we come back here to the plenum. Of course, first, Josephine is also going to give some introduction, what we exactly do and where we find which kind of material. And then after coming back to the plenum to report back a little bit by using information that we have deposited in the mural, we go again into the action 2. Not again, but we go into action 2, and then after some instructions again provided by Josephine on the basis of our Planet's internal SSbD workflow, fill out this form for the motivation for substitution, so the why. What is, and also prioritize there. So we need not fill it completely. We actually want to really just highlight the most important friction points in the different dimensions for SSbD. And for this, we keep maybe up to 15 minutes in a kind of loosely discussion style. Deposit also the pieces of information that we consider in our breakout groups to be most relevant. And then we come back to the plenum again, report to each other. Maybe we have quite similar suggestions anyway, then this will not be a very long action in the plenum. Maybe it's quite heterogeneous, so we can discuss a bit about it. And then we go into a little bit more extensive action 3, which is then to define the redesign and the system boundary, the boundaries of the system, basically. Yeah. So there we have to go through a kind of series of different questions which were raised already by Sabine earlier in the method when she was reporting for the methodological guidance document, but these questions are also deposited in this workflow there. And we start now really working on our documents that we are going to be then also using later in our real cases. It will guide us through, for example, the identification of the purposes, reviewing again and selecting which SSbD principles are in the center of our study, at what design level, so material or chemical or process or product, we will be operating, and then also conduct the system boundary definition. This we will do by using this mural. And I asked one of my colleagues, and this has already been done by Mattis, I suppose. I see this here in the chat, to put it into the chat so you can pick it up and then we can gather there. So a few words on the substance. In this document, you would be also finding the most importantly, this important information about this material. So the DEHP, substance of very high concern, versus the two alternatives. If you want to have access to the CAS number and to retrieve more information, here it is. I won't say many things about it. What else you can find there is a very short description of the production of the plasticizer. Two-step procedure. I'm not going into detail of that. You see a little bit something on temperatures used, what the material is derived from, how it's built up. I mean, I guess all of you guys are chemists anyway, so this will be kind of maybe not maybe even look very trivial. Also for the ESBO and also for the ATBC ESBO. I mean, here for example, I highlighted a couple of acids that are maybe become relevant, and temperatures again to just to give a little bit substance for discussion in this along these different dimensions that may be considered. Yeah, there is not just the plasticizers themselves. I mean, out of that you need to form a plastisol. Needs to be produced, and then in the end, you also do this manufacturing of the gasket itself. Then a few remarks that were pulled out during this case study phase by the JRC on what is relevant maybe to the use phase. So I was reporting on these kind of issues, on these different parameters relevant for the use phase, and maybe also want to consider end of life. At end of life, since it's going to be burnt, is pretty similar for all of these, coming of course out of the consideration that it's a food contact material. Good. So I would say, before we go now into the breakout groups, I will organize that. Let us have a look again by Josephine into the technical value chain definition.
Thank you, Martin, for the explanation of the case study. So, as already mentioned, when I slightly present you the workflow in the scoping phase, we identify the who with the technical value chain. So, the idea of creating the technical value chain is to mapping out the steps and the flow of information in order to help the organization to optimize operations and to ensure a smooth coordination across different teams and activities. So we would like you to perform the technical value chain of the case study presented by Martin by using a series of interconnected processes and stakeholders that will contribute to the creation, development, and delivery of the final product, which is a gasket. You will define the role of the technical actors and outline their contribution at each stage of the product lifecycle. This will be a nice exercise for you to perform, because we are now in Planet in the phase of customizing the workflow to case study, and so this will be asked for the case study, for Planet case study as well. So I think we can go now on the mural, Martin, and begin working on the gasket technical value chain.
Good. Shall we switch to the next action? Here's objective 2.
Okay, so me again. Let's talk this time about the second parallel part of the scoping phase we designed in Planet, the motivation for redesign. So this aims to clarify why the focus is on substitution. We can refer to the negative impact of the substances within life cycle thinking perspective. So this part is essential to investigate all dimensions of the life cycle. As you can see on the bottom of on the top of the table, with the raw material and resources, processing and manufacturing, use and end of life. And the idea is to create a list of primary performance or functionality needs to ensure that any alternatives meet the same criteria while minimizing negative impact. So the priorities set by the case study on the right column should later on guide the weighing system for the final scoring. So we will not discuss about scoring today, but in the assessment part, that's something important. And Norbert also remind you that the scoping phase is the place to think already on the multi-criteria approach and the benchmark we will perform during the assessment. So during this exercise, you are asked, based on the case study information you have, to identify why we want to substitute DEHP for each dimension: hazard, exposure and release, environmental impact, economic and social, and for each life cycle stage. Some cells, maybe most of the cell, will remain empty at the end of the exercise. The idea is not to fill all of them, but just to identify the purposes of the redesign of the substitution. And to also set priority.
Let's dig into the last third action item, and I share the screen again and give the floor to Josephine to quickly introduce what's going to be done now in the redesign and systems definition. We are not going to be doing the regulatory landscaping, but the two items here. All right.
Yeah, so this time you will have kind of a rest, because I have, I think, 4 slides, consecutive slides, without any exercise between them. So you can rest and just listen. So now we move on the third action, the third objective about redesign and system boundaries definition. So in this block, we have 3 main actions: 2 consecutive, redesign definition and system definition, and 1 parallel, the regulatory landscape. This all stage aim to define the substitution or redesign purposes and principles to be followed for each case study. We will determine the system boundaries to prepare a smooth assessment phase. And in this slide, I want just to slightly show you what IPC had in mind for the regulatory landscape. They will perform this scoping phase, so you are not in charge of doing that. They will contact you, of course, to collect information and so on, but this will be performed outside of the case study. Now we will focus on the redesign definition and the system definition. And for this part, you will have some exercise to do, so be careful. Let's go on the redesign definition. So the redesign definition is divided in 3 parts. You have here the first one, which is the identification of the purposes. So here you have only 1 question which offer you a proposal for what are the goals of your innovation. For example, developing a new process, developing a new product. We want to increase the safety of the chemical during the application. We want to improve the environmental sustainability of the chemical or the materials, and so on. So you will have this question in a separate, in a dedicated PDF, which is on the folder of today's session. And during the breakout session, you will be asked to go back to this question and to find what are or what is the goals of innovation in the case study. Once the purposes is identified or are identified, we can go on the principles identification. So for the principles identification, Carla shown briefly on her presentation the SSbD principle published in the GRC SSbD framework. So here you have some of them: material efficiency, minimize the use of hazardous chemical, use renewable sources, design for end of life, and so on. So during the exercise, you will have the same. The question will be available on the PDF, and the idea will be to identify what are the SSbD principles relevant for the case study. Once this is done, so this is an iterative process, but also a hierarchized process. So we have to follow purposes, principle, and then the design. So we have talked slightly of the 3 levels of innovation: molecular, process, and product. So the idea is to identify at what level is the redesign of the case study. Molecular: is there any existing chemical materials that can be used as a reference to compare the result of the SSbD study? And then you have other solutions if no. And for the process design, does the improvement of the process require a new technology? And for the product design, does the redesign of the product application involve a new application? So the idea will be to identify among these 3 which is relevant for the case study. Once this is done, we can go on the system definition. So we move on the second part. The second part starts with the system boundary definitions. Once this is done, we can ask some questions about the chemical material. So this is really inspired by what Norbert and Sabine shown you. You know, the decision tree in purple and green and blue from the GRC methodological guidance. This is quite the same question. So for the chemical and material, you should provide the chemicals, materials, identity information, such as the name, the composition, and so on, the case number if you have, and so on. For the process part, the idea is to select the following sentence that represents the process under study. So you will have the question as well. Then when you want to do all the system definition, you can refine the system boundary definition with the chemicals ID. And if you have any other chemicals, you do it again. But in the frame of the exercise, we will just do it once. So system boundary definition, identification of chemical, process, and then third question about the product and the application, where we will define and detail the final product with the description of the product, the industry sector of the product, the function of the chemical materials in the product, and some product specificity. If you go on the next slide, I think we have an example of the system boundaries definition. Sorry, I have lost the word. So system boundary definition. What we are expecting for this is to go back on the technical value chain and to enhance it with information about the steps, the SSbD dimension we will assess for each stage. For example, here, so you have the gasket technical value chain from the framework applicability. So for example, with your precursor A, precursor B, then you have the processing and manufacturing, the use and the end of life, and the idea is to select where we will assess hazard, where we will assess exposure, where we will assess environmental impact, where we will assess economic and social impact, and so on. So this is a key point of the system definitions, and this will then nourish all the assessments that will be performed in the second phase of the SSbD framework.
Okay.
Now that you have all the information, I think we can go on the mural.
Yeah, I guess with any further ado, let's just check it out. All right, so with this, let me thank all the presenters of the meeting today. Josephine Steck from CEA, Carla Caldera from Ciensco, Sabine Hofer and Norbert Hofstetter from PLUS. And I wish you good luck and much of success with the practical exercise on SSbD scoping. Thanks for listening. Bye-bye from the Planets Project.